Okay, we're going to go ahead and finish our foldable. So we have done the entire thing except if you open it up, the very bottom left. So remember, all the time when we factor, the first thing we want to do is to make sure that we factor out a GCF. So always first check to see if we have a GCF and factor that out. After that, we select whether or not we want to go to a trinomial or a 4-term polynomial or a 2-term binomial. So yesterday we did binomials. So we're going to focus on this column. So we did the perfect squares yesterday, but we did not do the perfect cubes. So we're going to go all the way down to the bottom of our left column and factor out, learn how to factor the difference or sum of two perfect cubes. So let's take a look. So when we get down to the bottom of the very left column, it says if you have a binomial that is the sum or difference, so it could be adding or subtracting, of two perfect cubes. So yesterday we did perfect squares. Today we're going to do cubes. So what is a perfect cube? Perfect cube is when you have something like 1 to the third power. 1 to the third power means 1 times 1 times 1, which is just 1. Or if we had 2 to the third power, that's 2 times 2 is 4 times 2 is 8. What if we had 3 to the third power? That's 3 times 3 times 3, and that's 27. So these are going to be our perfect cubes. So in your notebook, we have a little space for perfect cubes, and we can go ahead and write those perfect cubes. So the smallest one is 1, because 1 times 1 times 1 makes it. The next one is 2 times 2 times 2, which is 8. The next one is 3 times 3 times 3, which is 27. Then we have 4 times 4 times 4 is 64. 5 times 5 times 5 is 125. And we can keep going with that list forever. Remember, we can also have variables. So what would be x times x times x? That would just be like x to the third power, right? You could have any variable to the third power or y to the third power. You could even do, what if I had 2 x's and I was doing that to the third power? I could have like x to the 6th. That would be a perfect cube. And we can keep going with this list also. So anything you can multiply by itself 3 times is going to be a perfect cube. So we're going to be looking for those. Now notice up here we have 2 different formulas. So if it's the sum, we use this formula, right? If it's the difference, we use this formula. They look almost the same, except for some of the additions and subtractions are in different spots. And no, you don't have to memorize those formulas at this point. Okay, so let's go ahead and see if we could factor this one. This is clearly a binomial. So what's the first thing we always check for? Always check for GCF first. So if we were to make a little chart for this 2y to the 4th, we have 1 times 2. We'd have y, 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 y. This 54, now obviously you're going to have 1 times 54. And then 2. How many times does 2 go into there? 27? And then we have just 1y, right? Sorry about that ugly 27 right there. So we don't have to go any further because our biggest number in our first one is 2. So we see that our GCF is going to be a 2 and a y. So let's go ahead and factor out a 2y. So put 2y outside, dividing 2y out of everybody. If I divide 2y out of the first term, I'm left with just 1y to the third. If I divide 2y out of the second term, I'm just left with 27. So now I do have a binomial, so I have to see if this is the sum or the difference of 2 perfect cubes. So this first term, 1y to the third, is that a perfect cube? Perfect cube means 3 of them won't exactly make it. So if I did 1y times 1y times 1y, that certainly makes 1y to the third. 27 is definitely in our list up there. So what number makes 27? A 3 times a 3 times a 3. So we do have perfect cubes. And this right here is sum, right? It's an addition. So that means we're going to go up to the top and we're going to use our sum formula, which is way up here. We're going to be using this formula. So I'm going to copy the formula down here so we can see it. So our formula is, if we have a to the third plus b to the third, our formula is a plus b, close parentheses, next set of parentheses, a squared minus ab plus b squared. All we have to do is identify a and b, and we could plug them right in. So looking up here, we're going to get our a and b from right here. This is going to be our a, and this is going to be our b. So a is going to equal 1y, and b is going to equal 3. So just like before, we're going to ignore that GCF on the outside and put that on our answer when we're done. So let's go ahead and plug in our a and b where they go in our formula. So plugging them in, a is 1y plus b is 3, parentheses, a squared, that's 1y squared, so that's 1, okay, minus whatever a times b is. So a is 1y and b is 3, so that makes 3y plus b squared. Our b is 3, so what is 3 squared? That is 9. And then we had to put our GCF right on the front, 2y. This is factored.